how your friendly neighborhood JDK protects you. A little bit about me. My name's Theresa Mammarella. I'm a developer advocate at Sonatype and also an open source developer. I've worked on several different JDK and compiler projects in the Java space, including OpenJ9 and also Cubic, which is a static compiler like prototype project. But my current job at Sonatype is helping improve open source projects, improve their security, knowledge, and awareness, and posture. So in my talk today, we're going to talk about application security, so frequently made application security blunders, and then specifically for Java, security best practices. Welcome. Discover people. You're everywhere. So as I was saying, I'm going to talk first about commonly made application security blunders, security best practices specifically for Java, and Java 17 features that you can use to help remediate some of those commonly made blunders and help make code a little bit more correct and a little bit safer. So as you may have seen over the last 2 or 3 days, depending how many days you were at this conference, there seeming to be more security talks in 2022 than I have ever seen in prior years. And that is because in the last 5 to 10 years in particular, the implications of having a security vulnerability have grown exponentially. And so one of the narratives that we like to tell at Sonatype that I think is fun is that cybercrime is now officially bigger than the drug trade. And it's been studied that the global cybercrime damage is approximately $6 trillion every single year. So it's a pretty big deal. Another thing that you've probably heard in the last few days is about the software supply chain and how it needs to be secured. This isn't strictly a developer problem. It's more of a DevOps and a security problem, but it's something that we're striving to make developers as well aware of. And if you haven't heard of it, this concept of a software supply chain essentially comes from manufacturing. And the way we think of physical supply chains can also be applied to software. So suppliers are third-party open source libraries. The warehouses are component repositories. Manufacturers are software development teams. Finished goods are software application. And the idea is that if we protect ourselves from the dependencies that we're using and scan them and do all sorts of tricks to make sure they're secure in enterprise applications, then we're going to be a lot safer and remediate a lot of dependencies. But at the end of the day, those libraries, those dependencies, they're written by developers just like you guys. And the long answer to a lot of this is that developers need to have a little bit more security education and be more aware when coding of potential concerns. In fact, I found this in a study kind of recently that from the Cybersecurity and Infrastructure Security Agency paper on securing the software supply chain, they categorized an insider threat. If you're not familiar, the potential for an insider to use their authorized access or understanding of an organization to harm that organization. And one of the things on that list that could be an insider threat for the software supply chain is actually the naive or poorly trained engineer. So I thought that was kind of interesting and really brings home the point that this is something that more and more needs to be considered. So had some resources for learning for y'all in case you are so inclined to take on this challenge of stopping or at least being part of the solution towards writing secure applications. So the first one that I'll be talking a little bit about today is the OWASP Top 10. There's a lot of good security information and Java best practices on reputable blogs. for the Java community like Fujay. The Linux Foundation currently has a free course on developing secure software. And you can also get a nice little LinkedIn badge if you complete that, which is always fun. And finally, if you're not already familiar with it, Oracle also has secure coding guidelines for Java, and these are specifically around security issues that happen with Java coding. All right, so as I mentioned, we'll talk a little bit about the OWASP Top 10. This, if you're not familiar with it, is a list of the top 10 most critical security risks for applications, the types of security risks, and it's published by the OWASP Foundation approximately every 3 or 4 years. And this is a really good list to make yourself familiar with, because this is backed, by data of vulnerabilities that have actually happened. And so the last one was done in 2021, and before that was 2017. And the point I wanted to make showing this slide was that a lot of them have actually stayed sort of the same over time, with a few new ones. Excuse me. And if you dive deeper into these OWASP top 10, what you'll see is a big old list of something called a CWE. And so I wanted to just go over that a little bit in case the developer audience isn't always familiar with these security terms. So what that is a common weakness enumeration, and it's basically a category of a type of vulnerability. And this can be from software to hardware, but because OWASP is focused on applications in particular, that's the ones that you're going to find in this list. Now, I think the security acronym that comes up a little bit more often than this is CVE, which is likely something that you've heard over the course of this conference if you've gone to any of the security talks. And what a CVE is, it is a report of a specific vulnerability that has been a proven exploitation and shown that it is in fact possible for someone to go in and exploit that risk. But the CWE is, as I mentioned, just the concept that it could be possible for this to happen. So this is something we often hear about the CVEs a little bit more because it is an active flaw that we should potentially care about. The issue is that these CVEs, when they're published and when they become public, are becoming exploited faster and faster. Oh, another study that I found from the Cortex Expanse Attack Surface Report shows that actually when a CVE comes out, you can expect scanning of on addresses that will happen within 15 minutes potentially. Now, we heard from Brian Demers a couple hours ago that for Log4j it actually took, despite this, 2 days for the first known exploitation to be to be found. But it can happen in as little as 15 minutes. And the study also said that it takes approximately 12 hours for development teams to actually start looking at this compared to the 15 minutes. So that is why it's important to be aware of these common weaknesses and not just the CVEs that already exist, but to be coding defensively and learn about secure coding for the case when a vulnerability does come out. Hopefully your applications and those libraries that you're using that are also coded by developers will be protected. So the one that I want to focus on today is the number one security risk on the OWASP list, which is broken access control. And this was found by OWASP to affect 94% of tested applications. And the secure coding guidelines for Java that I mentioned actually talks quite a lot about this. There's a section all about accessibility and extensibility, and some of the guidance around this are things like limiting the extensibility of classes and methods, limiting the accessibility of them, so public, private, all terms that we're all pretty familiar with as Java developers. Using modules to hide internal packages. The other section that pertains to this topic is serialization and deserialization. And some of the guidance around that is avoiding deserialization for security-sensitive classes. I mean, that really is the number one piece of advice, but sometimes you have to use it for possibly legacy code, or it may be used in those pesky dependencies and transitive dependencies. And so that's why it's now being recommended to still filter for serialization, even in cases where you might not be aware that it's even being used. So I'm going to take a minute to focus on each of these and talk about ways that in later versions of Java, you might be able to leverage some features to be able to do these a little bit better. All right, so in terms of limiting the extensibility of classes and methods, the guidance is as follows: to declare classes as final to prevent unauthorized subclassing, use composition over inheritance when designing applications. If you're not familiar with those terms, I'm sure most of us know inheritance as an is-a relationship, so creating a subclass from a superclass. But composition can be thought of a little bit differently, and that is a has-a relationship, such as, and this is going to be my example for my whole thing, my menu from my restaurant has a burger on it. And the final piece of advice is to be used for a little bit more nuance is to potentially use sealed classes where applicable. This is a feature that's new in Java 17, which is able to make extensibility of Java applications a little bit more nuanced and potentially a little bit more secure. So I'm going to go over exactly what that is in case you're not aware of it. So it was released as a full-fledged feature in Java 17, which is the latest LTE release that's recommended to upgrade if you're on Java 11. But it's also been in previews from Java 15 if you're keeping up with that 6-month release cadence. So the goal of this feature was to allow the author of a class or interface to control which code is responsible for implementing it, to provide a more declarative way than just access modifiers, to restrict the uses of a superclass, and support future directions and pattern matching by providing a foundation for the exhaustive analysis of patterns. And I'm not going to go into pattern matching today because that could be its own completely separate talk, but I will show you a little bit about how sealed classes can be used in that context. So the reason that this feature came about, or the background behind it, is that Java, the language, and the concept of object-oriented programming kind of assumes that the purpose of inheritance structure is always going to be code reuse. But that is not always the case. Sometimes we need to model data, and that may have limited extensibility. And in that case, sometimes inheritance and the flexibility that Java provides can be a little bit cumbersome. And in earlier versions, there's some pretty limited possibilities with that, such as making a class final if we don't want it to be extensible, but then it's not extensible at all. Or making constructors package private, for example, like the unsafe classes if we only want, for example, one object to be created there. It's a little bit clunky. And so the goal for sealed classes is that it should be possible to use a superclass, but not have it be widely extensible, which is part of the advice for limiting accessibility that could potentially be exploited. So again, I mentioned that I'm using a restaurant menu as my example. I was a little hungry when I was making these slides. So I have my abstract class that is menu items, and my 3 menu items, which is burger, fries, and chicken strips. So this is a fully extensible inheritance. So with sealed classes, the changes look a little bit like this. So we can declare the abstract class as being sealed and have a permits list, which only lets a certain number of classes be inherited. So in this case, burger, fries, and chicken strips. And if I try to create a new one, or try to even bypass the JVM by loading in new classes, then it's gonna fail because I've only said only burger, fries, and chicken strips can possibly be a part of my restaurant. I would never consider any other food item. And as I mentioned previously, pattern matching also follows along really nicely with this feature because it allows switch statements to look a lot more cleaner and not have that default statement anymore. And it's a lot more possible to be sure that I have every single case that exists in that switch statement. Makes it a little bit cleaner, but also has the potential to be a little bit more correct as well. So this bit of code that I have here doesn't actually compile, and that's because of another restriction that gets imposed on sealed classes, which is that all of these subclasses actually need extensibility modifiers as well. So that can be final, that can be another sealed class that needs to have an explicit permits list, or non-sealed, which is the same as a default class. And so the non-sealed is intentional because it requires you to be explicit about that extensibility and say, yeah, it's okay for this to be completely open. If creating a sealed class in a subclass or with classes within a class, you actually don't need to have that permits list, and it's implied. But you'll still see that it's included there. And you can't do nested classes here like this and a permits list combined. Does not work. And yes, as I mentioned, you get an error. All right. So as I mentioned, sealed classes can help a little bit with that problem of extensibility that will come up, and helps to prevent unauthorized subclassing, encourages an opt-in with that non-sealed modifier for full extensibility, can provide potentially safer and more correct program logic with pattern matching. And if you're not on a version of Java that uses it yet, continue using best practices, of course. Mark classes as final where appropriate. Consider composition instead of inheritance. And one way to think about this, if you find a candidate that you're writing that could benefit from sealed classes, is write yourself a note that when you are upgrading to the correct version, that you can and will upgrade this pretty easily to get those benefits from pattern matching and also the limited extensibility. All right, so the next rule for accessibility and extensibility from the Secure Java Coding Guidelines is to limit the accessibility of classes, interface, methods, and fields. Now, this was pretty obvious. Classes and interface, or should be at least, classes and interface should be public if they're part of a public API, otherwise should be package private. And same with class members. They should be public if part of an API, or private otherwise. So the feature that may come in handy in terms of helping along with this is records. That one's actually fully released in Java 16, but again, assuming most people are keeping up with the long-term support releases, you'll probably want to see it in 17. And so records comes along a similar vein as sealed classes, as being able to model data in classes a little bit better. So data classes in Java can be pretty cumbersome at times and contribute to the stereotype about having a lot of boilerplate code for Java. It's just having equals, hash code, two-string methods that can take a while to write, but at the same time, if you don't have them, cause a lot of unexpected potential issues. Records are really useful because they help programmers just be able to create those carrier classes a little bit more easily. I think it did I think it's a little wrong here. All right. So the goals behind this was to devise an object-oriented construct that expresses a simple aggregation of values in those data classes, help developers model data rather than an extensible behavior like we talked about earlier. Automatically implement data-driven methods such as equals and accessors, and preserve long-standing Java principles such as nominal typing and migration compatibility. So what it looks like, more or less, is this. Instead of a class or interface identifier, there's a record identifier, and then this list of components here that are created as instance fields, basically. And the naming convention that you'll hear often used for this one is the record, which is more or less the class, and then the components, which are these individual instance fields. And it's also initialized just like a class. But what it looks like, this record looks like it when it gets compiled, and I used the class file disassembler to look at this, is first of all, we see what's different about this class is instead of extending Java-lang object as a regular object, it actually extends the record class, acts kind of like an enum class in this way. You'll also notice that the class is marked final despite me not providing that direction. All record classes are implicitly final because once data is created, likely the case is that it should not be changed. It also creates each of these components that was listed as instance fields that are private and final. Constructor, two-string hash code equals that I mentioned before can be error-prone and potentially be boilerplate code, but all these can be overridden. And then accessor methods for each of them. So you get all of this code in basically one line of Java. Well, the only fields that can actually be declared inside this class, all this can be overridden, except that you can't create any more instance fields other than the ones that are actually declared when declaring a record here, such as the burger bun, the protein that I might be using, and the toppings. All right, so see if you all are paying attention. Actually, this is kind of a trick question, but just to check if this is legal code, using sealed and record classes together. So typically for a sealed class, as I mentioned before, they all need to have an explicit access modifier, but because records are implicitly final, you can use them together in this way and have a very nicely compact way of expressing some data. So if you're not on Java 17, again, record classes, they provide a way of writing code quickly and potentially error-free. But all of it just enforces best practices. The proper use of these these permissions and also ways of accessing data are still achievable on any version of Java. When you're on 17, consider constructing new data classes as records. It may make sense if you're interested, again, in those uses of pattern matching to transition existing classes to records, but not necessary. So again, records can help with that accessibility and extensibility by providing strict accessibility for data classes, which have a high likelihood of storing sensitive information. Instance fields are only accessible through accessor methods, a good common practice, and classes are implicitly final, so there's no unexpected extensibility there. All right, and the final part about accessibility is using modules. You've likely already heard about modules if you've been around the Java space in the last 5 years. The benefits, according to the security guidelines, are strongly encapsulating classes, having sort of an allow list for accessibility of packages instead of them being all fully accessible. And coding recommendations minimize usage of command line options to override modularity restrictions. And the thing that I'm going to talk about in a little bit is basically that is getting harder and harder to do. So have all of you guys heard of modularity in this room? Are you all familiar? All right. In that case, I will just give a really quick overview. Are people on Java 9 and above? Yeah? Okay, cool. So you're already using this, and you don't necessarily need to use it further. But just to make sure we all have the background here, what the module system is basically doing is, so in Java 8 and below, all the libraries that you get with the JDK, they have packages, they have classes, but that is the highest amount of encapsulation you'll find. With modularity, there is an extra level of encapsulation here that increases the amount of permissions and the flexibility that you may have in order to access classes. So in Java 9 and above, the entire Java platform is divided up into these modules, based on different functionality. So you'll see Java base at the top that has all of the common sort of Java lang types of classes you'll often see, so object, string, system types of things. And that one is necessary to even start up the JVM, so that one is required at all times. There's a lot of information, of course, circulating around that it is possible to apply these concepts to applications as well. But again, not necessary to be able to take advantage of some of this added security. If you do that, you'll be running on something called the module path. Otherwise, it's a regular old class path, and this has basically been named the unnamed module because it is sort of implicitly its own module, but it requires all the JDK modules that are there. So I mentioned before, modules kind of have an allow list type of model when it comes to accessibility. And so this is kind of what it looks like if you haven't dove into this code. So we have typical packages, classes, and then there's this special file right here called moduleinfo.java. And every module has it in the JDK. First of all, when it's formatted, every module has a special name. And then this module info file, and it says basically if this module requires any other modules to run, but then also what is accessible to the outside world. So this exports right here says everyone can use this package who wants to, but you can't use anything else. So, I mean, the purpose behind this really is that if evil code package comes to my Java application and wants to use some internal code, they can't do it. That's awesome. But if I allow that module to explicitly, then it can. There's a lot of different things that can go into those module info files as well that I'm not going to spend a whole lot of time on, but ways to qualify and not make them, very specific in terms of what can access what. So in terms of reflection, that is also restricted, despite perhaps using that fun set accessible true to be able to access private fields and methods. But those can be overridden as well using those exports that I mentioned before, and also opens, which basically opens at runtime to have reflective access to that package. All right, there's also ways of expressing service providers in a modular way. And so in summary of that, you'll often find when migrating to Java 9 that a lot of the advice involves using command line options like this, adding exports and adding opens to be able to make that application still run. Because prior to this, it wasn't always clear or enforced that you shouldn't use internal packages that are now internal in the JDK. And so these have been really useful for migration. So the thing that's new here in Java 17 is that, at least for reflection, it's getting more challenging to just go in and use the packages that you want. And so the goal of this one was to continue improving the security and maintainability of the JDK and allow changes to internal JDK classes to continue to be internal, encourage developers to migrate from using those internal elements to standard APIs that are being recommended instead. And basically what this looks like is denying, by default, all reflective accesses. So this was another command line option that was introduced in Java 9, this illegal access. And that controls the openness of all the modules in the JDK. So permit was the default in Java 9, and it allows anything to be reflected by the unnamed module, which is the class path. In Java 16, it was deny was the new default, basically. The significant thing that was happening in Java 16 was it was deprecated for removal. And if you're not familiar with this term, this was another thing that was introduced in Java 9, basically saying that I'm not taking it away yet, but it's deprecated and it's going to be gone and it's going to break your build if you don't get rid of it pretty soon. This was kind of a new thing when Java 9 came out, because before that, Java didn't really delete anything. So something to be aware of if you're not already. So starting in Java 17, that illegal access option that you could turn on to just open reflective access is obsolete. It's just denied by default, and having that option there isn't going to break your build or anything, but it's not going to do anything either. But I think the thing I forgot to mention previously was some critical APIs that are supposed to be internal, like unsafe, will still be open, at least for now. So the other thing to mention when it comes to modularity and security, and actually Eric Koslow, if you were here at the FUJ Day on Monday, touched on it as well, is that there is a tool that comes with the JDK now called the JLinker. And it takes all those modules that are in the platform and is able to figure out like which ones you're actually using in your application. Because for something like serialization, if you're not using it, just get rid of it. You don't need that anymore. And then having less code will inevitably have less risk for security. So if you're not on Java 9 yet, sounds like a lot of you are, starting in Java 8, there's another cool tool called JDEPs. I don't know if that's how you pronounce it, but that's how I say it. And that is able to detect uses of internal APIs that you may want to consider changing if you're thinking about upgrading to Java 17. And then if you are on a version that has this illegal access, just at least turn it to warnings so that you're aware of what might break if you decide to upgrade to Java 17. All right, so we've gone over lots of new features concerning accessibility and extensibility, limiting extensibility with sealed classes, limiting accessibility with records, and using modules to hide internal packages. The next part I wanted to go over was serialization and deserialization. And the guidance there, avoid at all costs, please. But as I mentioned before, the amount of security education that developers sometimes get is limited. And also could be that like an older application just may not have the resources to be able to change this. But even if you personally aren't using serialization, it's possible that one of your dependencies is. And so if that is the case, I would advise to consider creating filters around this that can be done at the JDK level to even cover those cases where you may not know serialization is being used. So if you're not familiar with it, serialization is a way that was created for a long time in Java to be able to send information, basically transition classes and objects into a byte stream to be able to send them over a network to another Java application or microservice type of thing, and then uses reflection to be able to put all that back together into a reasonable class. The thing that was dangerous about this is that there's not a lot of built-in security around this, and the use of reflection can bypass a lot of safety checks that may be already existing in terms of accessibility and extensibility. So one example of a deserialization exploit that we've hopefully all heard of by now is log4j. And so if you're not familiar what happened with this one, log4j is a logging tool that a lot of people in Java use. And this was a CVE with a CVSS score of level 10, which is the worst. And the exploit was basically, if as a user, I'm able to input some user data that gets logged, then I can actually put in this JNDI request, which will basically call a remote server and get back a potentially bad class, deserialize it, possibly not check it, and you have malicious code then running in your Java application. So there's a lot of reasons why deserialization should be avoided, but that is just one of them. But in Java 9 and also 17, there are some ways to be able to filter around this, just in case. All right. So the filter basically allows you to filter by an allow list. So just allowing certain packages or classes to be deserialized and not denying everything else. Denialists, if there's specific classes that you think shouldn't be in there, you can add that too. Or some different metrics, like the depth of the graph. Deserialization works via recursion, so there will be some kind of graph when you have a class that uses another class, basically. Number of internal references, class references, number of bytes of that class, and array size. And that can be done with a system property. It looks a little bit like this. So the first example blocks this example sum package, allows example sum package, everything else that's in there, and then blocks everything else. That's what this exclamation point is being used for. That is the blocking. And the next one is with the metrics that I mentioned earlier, that you can have limits on the types of classes that are being done. So for example, if you're able to see that like, something bigger than this would be unreasonable for my current application. So that must mean something's gonna miss. I'm gonna block it. These filters can also be done in code. And that method or class that you pass in to be able to do that logic will return if it's undecided, allowed, or rejected to be able to deserialize that class. You can pass in a lambda expression, kind of like this, classes or methods. And these can be set to specific input object stream in cases of serialization, or it can be set as a JVM-wide type of filter, so applied to every case of serialization that may happen in the application. So in Java 17, this changed a little bit, and they added something new, and that was to create a filter factory for those JVM-wide serialization filters. So now instead of just being able to do it based on that object input stream, it's possible to do it based on a variety of heuristics such as modules or class loaders or various things you might be using, which could be possible in Java 9, but would be a little bit harder and potentially a lot more expensive in terms of performance and also developer time. So again, if you're not on 17 yet, they actually backported these features to 6, 7, and 8 because it's so important to be able to filter and defend against serialization attacks and deserialization attacks. So that's my advice. You probably have this already, so recommend using it. All right, so that's all my features from Java 17 for today. So we talked about that accessibility and extensibility, sealed classes, records, the modular JDK, to be able to maintain best practices. In terms of serialization, don't use it, please. But just in case, filter those potential uses of serialization. Once again, I recommend you guys check out those things that I mentioned before. The OWASP Top 10 FooJ blog has a lot of good security articles as well for Java developers. This awesome Linux Foundation course, I've gone through it. It's pretty good. And of course, the Oracle Secure Coding Guidelines, if you're not familiar with that. That's all I got. Oh wow, I thought I was going to be behind on time, but we're good.